Welcome, I'm Mr. Anderson, and this is the Algebra 2 help for section 5.4. I've selected 5 problems from the 5.4 assignment sheet, and I hope they're helpful. All right, problem number 1 here. All right, we are to factor the polynomial completely. All right, well, in distributing, remember that we multiply, and when we are factoring, we are dividing out. So I want to find what do these two terms have in common that I can divide out? I'm going to write this out again. 14x squared minus 21x. And I'm going to factor out something. I'm going to divide out something. What do these have in common? Well, they have a 7. They're both divisible by 7. And they both have an x in common. So let's divide that out. I can divide a 7 out and an x out. 7 and an x. All right, and that's going to be one of my factors, and I'm going to be left with some binomial. All right, this simplifies here, 14 over 7. That simplifies to 2 over 1, and this cancels out one of those x's. So it leaves me an x there. And this simplifies here to 3 and 1, and these x's cancel out. So that leaves me with 2x minus 3. And there we have it, factored completely. We can double check our work distributing. 7x times 2x is 14x squared. 7x minus 3 is 21x. All right, let's move on to the next problem here. Problem number 3. All right, factor completely. Let's see. We factor out, we see that right away it's got an x in common. Each one of these terms has an x in common. The numbers, this just has a understood 1 there. I can't really factor out a 9 or anything like that, or a 3. So I'll just factor out the x, and that will leave me with x squared here for my first term, plus 9x plus 18. Oh, and look at the miraculous thing this does. This leaves me with a quadratic that I know how to factor. Let's use the x method, organize our thoughts. Put a times c on top, b on the bottom. So we got 1 times 18 is 18. Drop the b down, b term down, that's 9. What multiplies up to be 18 and adds up to be 9? Well, 6 and 3 multiply up to be 18, add to be 9. And let's not forget this factor out here that we factored out originally. All right, and the two factors for this trinomial here are x plus 6 and x plus 3 then. All right, so there we have it, factored completely. X times x plus 3 times x plus 2, or x times x plus 6 times x plus 3. All right, on to the next one. All right, here we have a cubic. And if we look on page 354, I think it is, in our text, it will give us kind of a little formula. And it tells us that a cubed plus b cubed, see if I can get this right here, equals a plus b times a squared minus ab plus b squared, I believe. That's it. All right, so we have to relate our expression to what they gave us here in this formula. Well, this is x cubed, or x times x times x. All right, so this relates to that. So a is x in this formula they gave us. All right, this would be x cubed, or a cubed. All right, and then we have to figure, okay, what times what times what, or what's the cubed root of 125? Well, 5 times 5 times 5 equals 125. All right, so therefore b equals 5. All right, and I'm just really going to fill in. The formula they gave me here. So I'm just going to relate this to this here. So A is x. I got x plus 5. B is 5. All right. A again. I got x squared minus a times b. That's 5x plus, and then b squared, which is 25, or 5 squared. All right, so I really just filled in the formula that they gave me. All right, now we take a look at this, and I've got a quadratic here. Is this factorable? Well, we can pull out our handy-dandy quadratic formula and factor this. We can't really use our x method on this. Let's take a look at the discriminant in the quadratic formula. We've got b squared minus 4ac. All right, so b squared, that is negative 5 times negative 5, that's 25, minus 4 times a, which is just 1, times c. So 4 times 25, that is 100. All right, so this is negative 75. And what that tells us, if you recall in our quadratic formula, this is negative b plus or minus, and this is over 2a. All right, so this is negative 75 in the under the radical here. And then anytime we have a negative number under the radical, we're going to get an imaginary number. Really, we're getting two imaginary numbers because we have plus and minus. So the other two roots are imaginary here, and you can sort that out with the quadratic formula if you like there. All right, we're going to take a look at the next problem though. Problem number 7. All right, this one looks a little different. We have x cubed plus x squared plus x plus 1. And we're going to handle this a way that we similarly did when we did the full x method earlier in the year. I'm going to group the last two and the first two terms together. And if you recall, when we did the full x method, we would expand out our middle term in the quadratic expression that we had when we were factoring it. And we'd split it into two, and then we'd break up the first two and the last two terms, and then we'd factor out, we'd have the same binomial and factor something out of that. And that's the exact same thing I'm going to do here. I want to find a common binomial in this here. Well, factor something out here, it would have to be x plus 1, because I can only factor out a 1 there. So what would I have to factor out to get this to be an x plus 1 over here? Well, I could factor out an x squared. I can double check this by distributing. X squared times x is x cubed. X squared times 1 is x squared. And then, of course, 1 times x plus 1 is x plus 1. All right, and then if you recall when we did the x method that these two things that we factored out, that was our first binomial, x squared plus 1. And then our second binomial was the binomial that was in common, x plus 1. All right. And important thing to note here is that this is FOIL in reverse is what this is. If we were to FOIL, we would take we'd multiply these first terms, right? So this would be x squared times x, and then we'd multiply, so we'd multiply these first terms. Then we'd multiply the outside terms. That's the f and the o of FOIL there, right? And that's what we're doing here. X squared times x squared times 1. That's x squared times x squared times 1. That's the f and the o of FOIL. And then the I and the L of FOIL right here. All right, the I and the L, let me do that in black, I guess. The I, the I and the L in FOIL. All right, there's the inside term and the last term. That's 1 times x and 1 times 1. That's this right here, 1 times x and 1 times 1. So we're doing FOIL in reverse by doing this grouping method. All right, let's take a look at the next problem here. Okay, same thing. I'm going to find some sort of common binomial that I can factor out of this here. All right, and I'm going to rewrite this x cubed plus 5x squared. And then I'm going to say plus a negative 9x, and this is pretty much my preference. I like to have my negative on the inside here when it's on the right there, and I always like to leave a plus sign in between my two binomials when I'm factoring something out. All right, so I got to kind of use my intuition and see what kind of common binomial can I get here. All right, well, I take a look at this, and x plus 5 sure is standing out. I've got an x squared that I can factor out of this, and over here, if I could get an x plus 5 if I factored out this negative 9, because that would change the sign over here. That would just leave x, and that would change this sign. Factor out a 9, that would be leaving x plus 5. So kind of a little bit of eyeballing it with intuition, and I got a strong feeling I can factor out an x plus 5 from this. All right, I have a feeling they have an x plus 5 in common. All right, so I got to see, okay, what can I factor out of this to get it to x plus 5? Well, we said I can factor out an x squared. All right, so let's factor out an x squared. Double check x squared plus or times x is x cubed. X squared times 5 is 5x squared. Good. And then over here, I can factor out a negative 9. All right. Negative 9 times x is negative 9x. Negative 9 times a positive 5 is negative 45. All right, so again, here is our first binomial, x squared minus 9. Oh, look at that nice perfect square that we can factor. And here, the binomial in common is x plus 5. So let's, I'm going to shift this up just a little bit. Let's factor this right here. We know that this perfect square can be factored to x plus 3x minus 3. Factor that out, and then we'll carry that down as well. That's one of our factors, x plus 5. All right, so there we have it. The factors of this this polynomial in number 9, x plus 3, x minus 3, x plus 5. All right, well, I hope this little tutorial was helpful for you, and I will see you in class.